Bismillahirrahmanirrahim. Welcome to the second part of this lecture, which is finding the volumes of solid by cylindrical shell method. This shape on the screen is called the cylindrical shell. And as we stated before, the volume for this shape is given by volume equal to A to B of the circumference of the circle or the base multiplied by the height, which is given by the function f of x or g of y, depending on which direction we are rotating the solid. But for this one, we are rotating about the y-axis. We get that it is 2 by x multiplied by f of x dx. This was the general form for finding the volume for the cylindrical shell. To apply this formula for finding different solids, let's have some examples. Use this example. Use the method of cylindrical shells to find the volume generated by rotating the region bounded by the given curves about the y-axis. Now we are given different curves, y equal to the square root of x, y equal to 0, x equal to 4, and this will enclosing some region, R. And we need to rotate this region about the y-axis. So if we graph the three curves or three equations, y equals the square root of x, I will have this shape. This is this one. This is y equals the square root of x. And we have y equal to 0, which is the x-axis. This is y equal to 0, and vertical line x equal to 4. So my enclosed region is this one, the yellow. This is region, or my region there. And I need to rotate it about the y-axis. In the previous lectures, we found the area for this function using the rotating or the disk or washers. This will give me a disk if we rotate it about the x-axis. But in this lecture, I need to rotate it about the y-axis, which means I need to graph a vertical typical rectangle, not horizontal. Be vertical to the x-axis. If we need to rotate about y-axis using the cylindrical shell, so we graph a vertical bar or vertical rectangle on the x-axis and rotate it about the y-axis. This will give me another bar on the other side, like this. And if we rotate it, we'll have cylindrical shell, similar to this shape. This is my cylindrical shell. So the volume, in this case, is equal to the region R is included between 0 to 4. So the limit of the integration is 0 to 4. 2 by x. This radius of the circle is x. Because we are rotating about the y-axis, we are using x variable. If we rotate it about the x-axis, we are using y variable for the cylindrical shell method. Multiplied by the height. The height of this rectangle, which is this height, given by the function f of x. And if we have two functions, I will say the upper function minus the lower function. I have y equal to square root of x and y equal to 0. So the height for this one is equal to square root of x minus 0, just to make it general. This will give me, I can take 2 by outside, 0 to 4, x times square root of x, because this will be x multiplied by x to the power 1/2 dx. It is equal 2 by integration from 0 to 4 of x to the power 3 over 2 dx. Now integrating x to the power 3 over 2, I will have 5 over 2. So this can be written as 2 by multiplied by 2 over 5. X to the power 5 over 2 between 0 and 4. Using the fundamental theorem of calculus, this is equal to 4 pi over 5 multiplied by. Use the upper limit and lower limit for the integration. It will be 4 to power 5 over 2 minus 0, which is equal to 4 pi over 5 multiplied by 32. And this is equal to 128 pi over 5. And since we are looking for the volume, we say it is cubed unit. So this is the volume for the solid by obtaining the cylindrical shell about the y-axis. Let's have another example. But that we have this function, so y equal to square root of 5 plus x squared, y equal to 0, x equal to 0, and x equal to 2. And we need to rotate it about the y-axis. Again, this is about y-axis. The graph for this curve, the first function y equal to square root of 5 plus x squared is given by this. This curve is y, it is the upper half of the hyperbola, because this is equation of the hyperbola. So this is y equals square root of 5 plus x squared. Y equal to 0, it is the x-axis. And we have x equal to 0, it is the y-axis, this line. And x equal to 2, another vertical line. This is x equal to 2. So my region now includes between all of these equations, it is this area. And to rotate it about the y-axis, again, we graph a vertical rectangle there. Vertical rectangle. And rotate it about the y-axis means we are going to have another one there, the other side. And this will be the cylindrical shell that we have or are looking for. So the volume for this one, V is equal to the limit from 0 to 2. We are using the x variable because this is about the y-axis. We are using the limits of the x variable, not the y. About the y-axis, we are using the limit of x variable. This is the cylindrical shell method. This is not disk or washer. This method is different from the previous one, where we find the volume by disk or by washer. And we have 2 by x multiplied by the height of the rectangle. The height, again, is the upper function minus the lower function. This is the height, which is square root of 5 plus x squared minus 0. So we can write directly, this is 5 plus x squared dx. So the volume now is equal to, I can take 2 by outside, 0 to 2 x square root of 5 plus x squared. Now this integration can be done using integration by substitution. Let u equal to 5 plus x squared. Then du will be 2x dx, or dx is equal to du over 2x. So the integration now will be equal to 2 by x times u to the power 1/2 times dx, which is du divided by 2x. Now for the limits, if x equal to 0, replace x by 0, we'll have 5. And if we replace x by 2, we'll get 9. So the new limits will be from 5 to 9. Since we are using integration by substitution, sometimes we need also to change the limits of the new variable of the integration and using the limits or the values of the new variable, which is u equal to 5 plus x squared. Now simplify x with x, and also these two can be cancelled with these two. So I will have 1 by integration from 5 to 9 of u 1/2 du. That will be equal to by multiplied by, add 1 will be 3 over 2, so it is multiplied by 2 over 3 u to power 3 over 2 from 5 to 9, which is equal to 2 over 3 by multiplied by 9 to power 3 over 2 minus 5 to power 3 over 2. And this can be calculated using the calculator to find the exact value. And we can write the volume is cubed unit. So this is how to find the volume of a solid by the cylindrical shell method. In these two examples, we use cylindrical shell and rotate the given region about the y-axis. In the coming part or lecture, I'm going to find the volume by rotating about the x-axis.